Hi, fourth grade, and welcome back to Science Gizmos with Mr. G. Today we're going to be working on our next simple machine, which is levers. Yesterday we worked on our inclined plane. We looked at how, in our example, these ants that we were working with needed to figure out and use strategy with their inclined plane to transport different food items, like blueberries and almonds, for instance, up this stick, which was our inclined plane, on top of a stump, which is where they wanted it to be. We learned that changing the size and the angle of the inclined plane could make work easier and more difficult. We also saw that using more than one ant could increase the amount of effort or force used, which could make it easier and faster as well to do that. The same principles apply with our lever here. Now, a lever like this one here is a seesaw looking object or apparatus. We have our strong man here, who is going to be how we use our force. He's going to be pushing it down to see if he can lift these things. Our three objects being a pig, a turkey, and a sheep. And you can see they're labeled in measurements for weight. Levers are an object or a tool or a simple machine, whatever you'd like to call them, that we as people use to make work easier. Some real life examples of levers would be, for instance, a pair of scissors. A pair of scissors are two levers that come together to cut things. You also have a crowbar, which is used to pull nails out of wood or to move pieces of wood around in construction. You also have, for instance, your seesaw. Your seesaw at the playground is used to help lift each other up in a way that's a lot easier than if you were just to actually pick each other up with your hands. So today we're going to be experimenting with this lever here to see how much effort is used in our measurement newtons to move these objects here. So let's read what it says. It says, the strongman is showing off by lifting farm animals with a lever. Drag animals onto the lever, adjust the position of the strongman, and move the fulcrum if desired. Use the effort slider to raise or lower the lever. The lever has no mass. So they're saying that this lever has no weight to worry about. So we have a couple different components here. We have our strongman that we can move to be at different positions on this. So we can only go up to the middle here. This is going to change how much force is used. We have this is our fulcrum. Our fulcrum is at the point where the lever sits, and that can also change how much force is used. And then, of course, we have our animals here. We also have the effort, which is how much strength our strongman is going to put into this. So let's try a really simple one. Let's put him at 0 here, and let's do our smallest, our turkey. And let's see how much effort we need for this. Let's see, 50 enough? Nope. 100? Okay, so at 100, you can move them all the way up. Does that change with 200? Yep. So 200 newtons is the amount of effort that he will need to move that turkey up. Now what you'll notice is that we had to slide that to determine how much he would need to work. Let's work with our turkey again as an example. So we had 200 newtons to move it at just 0 with the fulcrum in its regular resting place. Let's see what happens if I move this fulcrum closer to the turkey. Okay. Let's see what happens at 50. So the closer the fulcrum is to the object that you're trying to lift up requires less effort. So let's see if the reverse is true. Let's see if we move this fulcrum closer to the strongman, if it will require more effort than the original 200 at the middle. So let's put it down here at, let's say, 1. Let's put our turkey here. So let's go back to 50 where we just were and see if that works. Not at all. How about 100? Nope. We had moved the turkey in the middle part where everything was standard at 200. Let's see if that works this time. Not at all. Maybe 250? Nope. Maybe 300. Not at all. What about 350? Wow. Okay. 300 and let's try just 400. 500? Okay, we're getting closer. 550? Okay, so that is a drastic change if you're moving this fulcrum all the way over to the strongman. When it was in the middle, it only took us 200 newtons. When the fulcrum was all the way to this side next to the turkey, it only required us 50 newtons to move it up. So you could say that the longer the length of the lever on the side that you're trying to move the object up, the more effort you're going to need. I'd be willing to bet that you required even more effort for heavier objects as well. Let's reset this to 3. Okay, let's put our turkey here, and let's see if our strongman, if we move him closer, let's put him at 2. Let's see how much effort is needed. Remember, it took us 200 newtons last time when he was all the way over here, and this fulcrum was in this position. Let's try 50. 100? No. 200. Okay, 250. So it actually required about 50 more newtons of effort as we moved him closer to the fulcrum. Now what if we move our turkey closer to the fulcrum? Let's try 50. Okay, so we can determine that if we move our strongman closer to the fulcrum, it requires more effort. But if we remove our object, in this case our turkey, closer to the fulcrum, it actually requires less effort. So there's a lot of different relationships here between the effort, the fulcrum, the turkey, well, the objects, including the pig and the sheep, and the positioning of all of those things together. So there's a lot of different combinations you can try, and this is one that is going to take maybe just a little bit of time to get practice and understanding with this. You're going to want to see what requires the most amount of effort and the least amount of effort in terms of positioning in different places. Once you've played around with this a bit and you got a good feel for it, come on down, of course, to our assessment here at the bottom, which I would highly recommend with these pictures is to simulate these pictures. So make your strongman, your pig, and your fulcrum look exactly like this, okay? With all of these. That is to help give you the best answer and to help, of course, guide you through a couple comparisons and examples within this. I look forward to seeing your work, and I will see you guys tomorrow.